Everything you own right now is part of a fragile, invisible miracle, and it is one mistake away from total collapse. The shirt on your body traveled through at least 4 countries before it reached you. The phone in your pocket contains minerals extracted from 3 different continents. The food in your refrigerator passed through a network of cold chains, distribution centers, and freight systems so complex that the people who run them use supercomputers just to keep track of it. We do not think about any of this until the shelves go empty. In 2021, a single ship, the Ever Given, ran aground in the Suez Canal. It was stuck for 6 days. 6 days. And it disrupted the flow of roughly 12% of global trade. Hundreds of companies could not get their products. Billions of dollars in goods were held hostage by a container ship that got slightly sideways in a canal. That was 6 days. Imagine 6 months. This is the global supply chain. Why? It is the most complex system human civilization has ever built. It is the reason you can order something at midnight and have it at your door by noon the next day. It is also the reason that when something breaks anywhere, the consequences ripple outward in ways that are impossible to fully predict. Today, we are taking the whole thing apart, every stage, every hidden layer, every fragile point. This is all of supply chain explained in 20 minutes. Chapter 1. Raw Materials and Procurement. Let's start where everything starts. The ground. Before a product exists, before a factory produces it, before a ship moves it, someone, somewhere has to pull a material out of the earth. Copper, lithium, cobalt, silicon. These are not glamorous words, but they are the foundation of everything you use. The smartphone you are probably looking at right now contains over 60 elements from the periodic table. 60. Most of them were mined in places you will never visit, by people whose names you will never know, using processes that have been industrialized to a degree that would be unrecognizable to anyone from a century ago. And the first challenge of the supply chain is this. How do you secure a reliable flow of those materials before you even know exactly how much you need? This is procurement, and it is far more strategic than it sounds. Procurement is not shopping. Procurement is war. It is the art of locking in contracts, managing supplier relationships, and forecasting demand months, sometimes years in advance. Companies like Apple, Toyota, and Samsung have entire divisions dedicated to procurement strategy. They are constantly asking, who are our Tier 1 suppliers? Who supplies our Tier 1 suppliers? What happens to us if a single Tier 2 supplier, a company we have never directly worked with, gets hit by a flood, a strike, or a trade embargo? The 2011 earthquake and tsunami in Japan exposed this problem in brutal terms. A single factory in northeastern Japan, a company that almost no one outside the industry had heard of, produced a specialized resin used in semiconductors. That factory was destroyed. And within weeks, automobile production around the world slowed down. Car plants in Germany, electronics factories in South Korea, all because of one factory in one town that almost no one had tracked. Modern procurement tries to map this entire web. It tries to trace every dependency, every single point of failure, every supplier of a supplier of a supplier. AI-driven demand forecasting now helps large companies model future needs based on weather patterns, geopolitical signals, and market trends. Sustainable sourcing has added another layer. Increasingly, companies have to prove that their minerals were not extracted using child labor or environmentally destructive methods, because consumers and regulators are watching. But here's the uncomfortable truth. No matter how sophisticated procurement gets, it is always operating under uncertainty. Demand forecasts are educated guesses. Supplier relationships can collapse overnight. And the minerals themselves, The lithium, the cobalt, the rare earth elements are concentrated in geographically and politically unstable regions of the world. The entire supply chain begins on a foundation that is, by nature, fragile. Chapter 2. Manufacturing and the just-in-time paradox. Once the raw materials are secured, they enter the manufacturing phase. And this is where one of the most influential and most dangerous ideas in modern business comes into play. Just-in-time manufacturing, JIT. The idea is simple. Instead of storing large amounts of inventory, which costs money, takes up space, and ties up capital, you coordinate your supply chain so precisely that materials arrive exactly when you need them and not a moment before. The production line never stops. The warehouse is always nearly empty. Efficiency is maximized. Toyota invented this model in the 1950s. It became the gold standard of modern manufacturing, lean, precise, no waste, and it worked spectacularly. For decades, JIT helped companies reduce costs, increase speed, and respond more quickly to changes in demand. It was so successful that virtually every major manufacturer in the world adopted some version of it. Then COVID-19 arrived, and the entire model broke. When demand for certain products surged, semiconductors, medical equipment, consumer electronics, factories that had been running lean had no buffer, no stockpile, no cushion. They could not absorb the shock, and the ripple effects took years to fully resolve. The semiconductor shortage that began in 2020 and lasted well into 2022 is the defining case study of JIT's failure mode. Car manufacturers who had cut their chip orders at the start of the pandemic, expecting demand to fall, found themselves locked out when demand surged instead. The chips were gone, and they could not simply order more. Fabricating new semiconductors requires specialized factories that take years and billions of dollars to build. So the pendulum has swung. We are now in the era of just-in-case manufacturing. Companies are building strategic reserves. They are reshoring production. They are diversifying their supplier base so that no single country, and in particular no single geopolitical adversary, controls a critical input. This shift has real costs. Maintaining larger inventories costs money. Redundant supply chains are less efficient. The lean machine of global manufacturing is being deliberately made slightly less lean in exchange for resilience. Meanwhile, the factories themselves are changing. Smart manufacturing, the use of digital twins, real-time sensor data, and AI-driven optimization is transforming production floors. A digital twin is a precise virtual replica of a physical factory. It can simulate production scenarios before they happen, predict equipment failures before they occur, and synchronize output with real-time demand signals from the other end of the supply chain. The modern factory is no longer just a place where things are made. It is a data system that happens to produce physical objects. Chapter 3. Global Logistics, Ports, Ships, and Chokepoints. Now the product exists. It has been manufactured. It is boxed, palletized, and ready to move. And this is where the supply chain becomes something almost impossible to fully visualize. Right now, there are approximately 50,000 commercial ships moving across the world's oceans. They carry about 90% of everything that is traded internationally. Everything. The oil that heats your home, the grain that becomes your bread, the components inside every electronic device you own. The system that makes this possible is containerization, and it is one of the most underappreciated revolutions in human history. In 1956, a trucker named Malcolm McLean had an idea. Instead of manually loading and unloading individual cargo at ports, a slow, labor-intensive, and enormously wasteful process, What if goods were loaded into standardized steel boxes that could move seamlessly between ships, trains, and trucks without ever being unpacked? The shipping container was born, and it did not just change logistics, it restructured the entire global economy. It made globalization physically possible. It slashed the cost of moving goods so dramatically that it became cheaper to manufacture products on the other side of the planet and ship them thousands of miles than to produce them locally. Today, the global container shipping network moves with a precision that is genuinely remarkable. Ships move on schedules coordinated months in advance. Ports, automated ports increasingly, process thousands of containers per day using massive cranes and AI-driven routing systems. The Port of Rotterdam, the Port of Shanghai, the Port of Los Angeles, these are not just ports, they are the circulatory nodes of the global economy. But the network has choke points, and these choke points are where the system is most vulnerable. The Suez Canal handles about 12% of global trade. The Strait of Malacca, the narrow passage between Malaysia and Indonesia, handles about 40% of global trade. The Panama Canal, the Strait of Hormuz, which carries a third of the world's liquid natural gas. These are not hypothetical vulnerabilities. They are known, mapped, and quietly terrifying to anyone who thinks seriously about global logistics. Every major power in the world has strategic plans related to these choke points. Because whoever controls these passages controls, in a very meaningful sense, the flow of modern civilization. Add climate change to this equation. Rising sea levels, changing weather patterns, and increasingly severe storms are already affecting shipping routes. The Arctic route, previously navigable only in summer, is opening up as ice melts, creating both a new commercial opportunity and an entirely new geopolitical frontier. The global logistics network is extraordinary. It is also navigating challenges it was never designed to handle. Chapter 4, The Last Mile, the most expensive problem in commerce. Here's a fact that surprises most people. The most expensive part of the entire supply chain, the most costly, the most complex, the hardest to optimize, is not the ocean voyage. It is not the manufacturing. It is not even the procurement of rare materials. It is the last mile. The last mile is the final leg of delivery. From a regional distribution center to your front door, it is short in distance, sometimes literally 1 mile, and extraordinarily expensive relative to every other stage of the journey. Why? Because scale collapses. An ocean vessel can carry 20,000 containers, all moving in the same direction. A last-mile delivery truck carries maybe 100 packages, each going to a different address. The efficiency math completely inverts. E-commerce has made this problem much more acute. When you order something online, you are not just asking for a product. You are asking for that specific product to be picked from a warehouse, packed, labeled, routed, and delivered directly to your individual address, often within 24 hours. You have come to expect this, and meeting that expectation costs an enormous amount of money and energy. The last mile accounts for an estimated 40 to 50% of total logistics costs. Companies like Amazon have spent hundreds of billions of dollars trying to solve it. They have built a network of micro-fulfillment centers positioned close to population centers, reducing the distance each package has to travel. They have developed proprietary delivery vehicles. They are testing autonomous delivery robots and drone delivery in select markets. But the psychological component of this problem is often underappreciated. The expectation of instant gratification, of same-day delivery, of packages arriving in hours rather than days, is not just a logistics challenge. It is a labor challenge. It puts intense pressure on warehouse workers who must pick and pack at speeds that have been criticized by labor advocates worldwide. It drives urban traffic congestion. It generates enormous amounts of packaging waste. The promise of seamless delivery to your door is real. The hidden costs of delivering on that promise are also real, and they are just invisible to the person placing the order. Solving the last mile is not just a technical problem, it is a social and environmental problem, and it is far from solved. Chapter 5: Systemic Resilience: How the Chain Survives Collapse. We have talked about the supply chain as a system that delivers goods forward, but there is another direction, reverse logistics, that most people never think about, and it is becoming increasingly critical. Reverse logistics is the process of moving goods back up the chain. Returns, recalls, recycling, refurbishment. As the circular economy becomes both an environmental necessity and a business opportunity, the ability to take a product back, process it, and reintroduce its components into the supply chain is no longer optional. It is competitive advantage. Apple now processes millions of returned iPhones per year through its Daisy and Dave robots, which disassemble devices and recover usable materials. The recovered aluminum, cobalt, and rare earth elements re-enter the manufacturing chain. This is not altruism, it is resource strategy. Beyond reverse logistics, the deeper question of systemic resilience has moved to the center of supply chain thinking. And three technologies are redefining what resilience looks like. First, real-time visibility. For most of supply chain history, companies had very limited visibility into where their goods were at any given moment. Today, IoT sensors, GPS tracking, and cloud-based logistics platforms give supply chain managers a live view of every shipment, every temperature reading in a cold chain, every container on every ship. When something goes wrong, they know immediately, and they can reroute, substitute, or escalate before a delay becomes a crisis. Second, blockchain-based supply chain verification. In industries like food safety and pharmaceutical distribution, the ability to trace the exact provenance of a product, from farm to table, from factory to pharmacy, is both a regulatory requirement and a safety imperative. Blockchain provides an immutable ledger of every transaction, every handoff, every verification. It makes the supply chain auditable in ways that were previously impossible. Third, glocalization. This is perhaps the most significant structural shift. After decades of global consolidation, of moving production to wherever labor and materials were cheapest, companies and governments are now deliberately relocalizing critical production. Not fully, not abandoning global trade, but building regional buffers, reshoring semiconductor manufacturing in the United States and Europe, building strategic reserves of critical minerals, creating supply networks that can operate even when global trade is disrupted. The supply chain is not just being optimized, it is being reimagined for a world where disruption is the default, not the exception. Chapter 6: The Verdict. We started with a simple observation. Everything you own is part of a fragile, invisible system. Having walked through all of it, the raw materials, the procurement, the manufacturing, the shipping, the last mile, the reverse logistics, the resilience strategies, that fragility should feel more real. But so should the miracle. The global supply chain is the most complex cooperative structure that human civilization has ever sustained. It involves billions of people, millions of companies, hundreds of governments, and thousands of daily decisions, all of them coordinating, imperfectly but continuously, to move the materials and goods that make modern life possible. It breaks sometimes, dramatically, the Ever Given, the COVID semiconductor shortage, the Fukushima supply disruptions. These are not failures of the system. They are evidence that the system is operating under conditions of genuine uncertainty, and that it recovers. The question worth sitting with is this: what does it mean to understand a system that most people, even most policymakers, do not think about until it fails? It means that understanding the supply chain is not just an intellectual exercise, it is a form of literacy. It shapes how you think about geopolitics, about climate change, about labor rights, about technology, about the things you buy, and why they cost what they cost. The invisible machine is always running. Now you know how.